Good morning all of you. In last video we discussed about the methods of project evaluations. Methods of the project evaluations. In that we discussed about that methods of the internal rate of return, external rate of return. These methods to calculate that internal rate of return, external rate of return, we can use present worth, annual worth or future worth methods. Present worth, annual worth or future worth methods. Now this is the next method of the project evaluation. So this method is called as a payback or payout period method. Payback or payout period method. So in this method we calculate that investment at what time or in how much period of time that investment is again recovered. Investment again recovered for a particular project. So this payback period of method, we have to find out in how much period of time that particular investment on that project is recovered. So that particular period is nothing but a payback period. So this in this method, so we go through this method. So if you consider a simple example, if suppose that in a household that old tube light is replaced by LED bulb. If old tube light is replaced by LED bulb, so old tube light, if suppose that old tube light consume electricity of cost 100 rupees per month, and if LED consume the cost of 90 rupees per month. So how much? So by replacing that tube light by LED bulb, there is a 10 rupees saving. So in how many months this? If suppose that tube light is replaced by that LED bulb, then how many period or how many months that required to recover that particular investment in that LED bulb? So that 90 rupees, 10 rupees we get per month. So we required 9 months. To get that investment on that LED bulb to recover completely. So this is nothing but a payback period. So in this example, there is a 9 month is the payback period. 9 months is the payback period. Now in this example, we do not consider that interest rate. So without considering interest rate, we can say that 90 rupees of that LED bulb is recover in 9 months. It is recover in 9 months. So this is payback period without considering that interest rate. If you consider that interest rate, then that particular interest rate is considered. With that particular interest rate consideration, that payback period is different one. So this payback period, we go through one numerical here. So one numerical is given here. So this is the tube light and LED bulb replacement. Is the very simple and very practical example. You can imagine what is the payback period with this example. So one example is given similar to that particular example we discussed here. So here one MIG welding machine is proposed to increase the productivity of welding operation. The investment is required is rupees 1,50,000 and the equipment will have a salvage value of rupees 25,000 at the end of its expected life of 6 years. The increased productivity attributable to the equipment will amount to rupees 40,000 per year after deduction of extra operating cost from the value of the additional production. So MARR is 20% per year. So what is the payback period? So here they ask to find out the payback period. So in this case, a MIG welding machine, productivity of that MIG welding machine is increased, and due to the increased productivity, some amount will get due to that improvement in the productivity. So here initial investment is given as a 150,000. Salvage value is given as 25,000 at the end of the sixth year. And 40,000 per year we get. 40,000 we get per year after deduction of that operating cost. And with MARR 20% per year, what is the payback period? So our previous example of tube light and LED bulb is without consideration of the interest rate, but here this interest rate is given as a 20%, MARR given as a 20% per year. So in this example we simply prepare a table like this. So first ignore these two columns, last two columns. First ignore these two last columns and concentrate on these three columns. Concentrate on these first three columns. So in these columns or in this table, end of year, EOY is end of year, new cash flow, cumulative present worth at I is equal to 0%. So first consider these three columns. So here 1,50,000 is the initial investment, so it put as a minus. 1,50,000 is initial investment, put as a minus, and 40,000 is addition. So this is the 40,000 we will get at each year due to some improvement is done in that MIG welding machine, and this 40,000 we will get at each year. 40,000 first year, 40,000 at end of second year, third year, fourth year, fifth year, sixth year. So these are the cash flow diagram. These are the cash flows for the particular welding machine. So if you calculate cumulative amount, with interest rate is equal to 0. Consider here interest rate is equal to 0. So with interest rate is equal to 0%, this is a simply cumulative. This column represents simply cumulative term or cumulative net amount for each year. So for zeroth or for initially starting of that MIG machine, it will remain as it is as a 150,000 minus 150,000. At the end of the first year, there is some addition or revenue of 40,000 per year. So this 40,000 plus this 1,50,000, plus here this sign is minus. So 40,000 minus this 1,50,000, it will become as a 1,10,000. Similarly, this 40,000 minus 1,10,000, it becomes 70,000. 40,000 minus 70,000, it becomes minus 30,000. 40,000 minus 30,000, it becomes now 10,000. 40,000 plus 10,000, it becomes 50,000. 40,000 plus 50,000, it becomes 90,000. So this cumulative net amount is calculated without considering the interest rate. But if you consider interest rate as it is given in that numerical 20% interest rate they given. So if with this interest rate, if you consider, then that particular present worth, now changes with consideration of this interest rate. And to calculate this present worth at particular interest rate I, we use this formula. Present worth is equal to F divided by 1 plus I raised to n. Present worth is equal to F divided by 1 plus I raised to n. Now this F is the investment. For that particular year. So F divided by 1 plus I is nothing but now 20%. I is nothing but 20%. N is the particular period of time. So with this substitution of this, with substitution of this particular values, we obtain this column. With this particular substitution of that particular values, we obtain this column. So this column we obtain with 20% interest. This column we obtain at 0% interest. So now cumulative of this particular present worth column at I is equal to 20%. So this is the cumulative. So minus 150,000 for initially it is remains same, minus 150,000. So for second year, end of the first year, addition of these two terms, 33,332 plus into bracket minus 150,000. So it becomes subtraction of both the terms. Again for this second year, end of the second year, there is a addition of these terms, 27,760, and addition of this term minus 1,16,668. So with this cumulative amount we will get like this. Cumulative amount we will get like this. So if you consider in this, when I is equal to 0, we get that payback period. We get that payback period at the fourth year. So this negative term now changes at the end of the fourth year. At the end of the fourth year, as a 10,000 without interest. So this payback period is considered n is equal to 4 years. So considering this MIRR 20%, this payback. Now if you consider this 20% interest, if you consider the 20% interest, in this column there is only negative sign, So it means there is no gain, or no output, or no profit by considering 20% interest. So this with 20% interest, there is no payback period we not get in the 6th year. Payback period we cannot get in the 6th year. So this is the right here. Payback is not possible by considering this interest at 20%. So this is the example of the net payback period of time. This is payback period of time. Payback period method. This is also we can consider. Another method is the benefit to cost ratio method. So in this method is used particularly for the public projects. So this method is used for the public project, and in this public project we consider benefits. We consider benefits of that particular project and consider the total cost of that particular project. And with this consideration we find out the benefit to cost ratio. And again, for this, to calculate this benefit to cost ratio, again we can use present worth method, annual worth method, or future worth method. But generally to calculate this benefit to cost ratio, present worth and the annual worth method is used. Calculate this benefit to cost ratio, present worth and annual worth method is used. And in this particular consideration of the benefit cost ratio, time value of money we consider. So it is not just a ratio of benefit to cost, but if you consider this time value of money, so we can consider that benefit to cost ratio is nothing but a ratio of discounted benefit to the discounted cost. So this is nothing but the benefit to cost ratio. We can also denote to the B/C. This is denoted by B/C ratio, or sometimes it is called as a saving investment ratio. So this is the benefit cost ratio. So this we can calculate it by using present worth method like this. Benefit to cost ratio is nothing but the ratio of benefits of the proposed project and total cost of the proposed project. And now by using present worth of this proposed benefits, present worth of that benefits of proposed project, and present worth of the total cost of proposed project. Now if you write here this present worth of the particular benefit and present worth of total cost. Now total cost of that project is nothing but the investment and the operating and maintenance cost. So this denominator now becomes total cost, now becomes investment plus operating and maintenance cost. So present worth of operating and maintenance cost we consider here. If salvage value, if that project have some salvage value after some year of time, then that salvage value we can subtract here. Then total cost becomes as a salvage value. It means some gain or some particular amount we will get after some end of the year. So this total cost now reduces due to addition or gain of that particular amount. So salvage value, if you consider salvage value, in this salvage value subtract here from this denominator I plus P, present worth of operating maintenance cost, minus salvage value with present worth factor, present worth of that particular salvage value, present worth of that particular salvage value. So with this formula we can find out the benefit to cost ratio. Now sometimes these benefits instead of these benefits we can get by giving some operating and maintenance cost, So sometime this benefit to cost ratio, instead of write only present worth of benefit, we convert or we shift this term, this present worth of operating maintenance cost in the numerator. So this benefit, instead of considering only benefit, we subtract this particular benefit amount minus this operating and maintenance amount, and divided by the investment. So this is the benefit to cost ratio. So we go through some numerical in this benefit to cost ratio. So benefit to cost ratio method is generally applicable to the public projects, and it is a ratio of the benefit of that particular project divided by total cost of that particular project. And again, to find out the particular benefit and total cost of the proposed project, present worth method or annual worth method we can use. And this is also called as a saving investment ratio. So by this method also we can evaluate or we can judge a particular project. Whether this is a economical or not. So here in this example, so this is the example given as a dam construction company has rupees 5 billion available for investment. Project X with yield and estimated rupees 0.75 million per year in benefits to the public on an investment of rupees 2 billion and annual maintenance expenses of 4.5 billion. So one project is given. There are two projects, X project and Y project. So in this X project there is some yield of 0.75 million per year, and investment of that particular X project is a 2 billion, and annual maintenance cost is given as a 4.5 million. So with this, and for Y project there is a required 4 billion with maintenance cost 7.5 million per year, and expected to produce annual saving of 5.5 million. And both the projects have same time or same period of time. Both projects run at same period of time, 30 years, and MARR value is given for that particular projects are 10%. So compare that benefit to cost ratio for each project and make a recommendation. So this we can say that evaluation of the product. So if you look at this benefit to cost ratio of X, so we have formula benefit divided by cost. Now benefit in terms of present worth and cost in terms of the present worth plus initial investment I. So this benefit we obtain per year. So this P by A factor comes here. P by A factor for 10% interest per year and for 30 years. Investment is a 2 million. Investment for that X project is a 2 billion investment. So this 2 into 10 raised to 6 plus this present worth of the annual expenses. Present worth of annual expenses is nothing but a 4.5 million. So 4.5 4.5 into 10 raised to 6, 4.5 into 10 raised to 6. So here it is a billion, it is billion, so it take 2 into 10 raised to 8. It should be here, instead of 6 there is should be 8, as 2 billion investment is there, 2 into 10 raised to 8, plus 4.5 expenses is in terms of million. So in for million there is a 4.5 into 10 raised to 6. In two bracket this present worth factor, this present worth factor, annual present worth factor. So this operating cost is a per year. So this factor is a for per year, P by A, 10% interest rate for 30 years. So just calculate this value and we will get 0.0291. Similarly, we will find out the benefit to cost ratio of Y. Only this amount is changing, With same formula we can find out. Initial investment is now 4 billion. Initially investment is 4 billion, 4 into 10 raised to 8. Here by printing mistake, instead of 6 there should be 8. Plus present worth of annual expenses, 7.5 million expense per year. So 7.5 into 10 raised to 6 into this present worth factor for per year. So here this present worth factor for this particular benefits 5.5 into 10 raised to 6. Present worth factor P by 10% 30 year. So calculate this and we will get 0.11. So by comparison of this both benefit to cost ratio is higher for this Y project, so we can recommend Y project, because Y is a benefit to cost ratio, Y is greater than X. Now if you look at this both values of benefit to cost ratio, these are less than 1, so both the projects are not profitable, but for in between these both projects we can select Y project, because the benefit to cost ratio is higher compared to the benefit to cost ratio of Y is higher than benefit to cost ratio of the X. So from both project we select Y project, but if you consider this benefit to cost ratio of both the projects, it is less than 1, so it is not desirable or not profitable. So we discussed in this topic about the project evaluation methods. So previously in time value of money we go through some methods: present worth, annual worth, future worth methods. In project evaluation methods we use these methods for evaluating some evaluating particular project, whether this project is acceptable or not. We give some recommendation by using some methods: internal rate of return, external rate of return, payback period of time, payback period method, or this benefit to cost ratio method. So we use this method to recommend particular project whether it is acceptable or not. And now in this we discussing about a particular project. One single project. But in the next topic we discuss about the different projects. We discuss about the comparison of different projects for a particular period of time.